everybody, it's Tyler here with members of the FTC Everybot team. This has been an incredible journey that hopefully you'll be able to catch and watch some of their awesome documented progress that they've had on here. We're going to be doing an awesome breakdown of this robot, talking about some of the design philosophy. Take a look at this awesome clamshell design on here, and of course the tape measure that they're using as well. But there's so much to break down with this, so let's dive a bit more into what this robot's offering and how they're impacting the community coming up here on Behind the Bot. So Elizabeth, let's talk about the design philosophy for the FTC Everybot. I'm just curious here, like why even design this in the first place, and let's break down a bit more about it.
So one of our main goals with designing the FTC Everybot was to stick to our 3 goals for our Everybot programs, which is to design a elegant, competitive, and affordable robot. So most of the parts on this robot, as you can see, are 3D printed, making them accessible for teams who as long as they have a 3D printer. And a lot of our parts that are not 3D printed, or these parts from suppliers, are things that you can get at any hardware store. So such as our drawer slides and our measuring tape here that we use for our extension.
So looking at something like this, what have been some of the results that you've seen so far out of creating this? Where have you seen other teams starting to replicate or implement or take inspiration from it?
Especially on Open Alliance and on Chief Delphi, we've seen a couple of teams try and implement this and be incredibly successful. We've seen some teams who have been to tournaments where they were the only teams who could score on the specimen or on the chamber.
And I think, looking at, I think one of the things too is that you're enabling a team to create and compete, and how important that is for some teams who might not even know where to start for stuff as well too, right? So we've seen, Everybot's been around a long time for the FRC community for it, but FTC, this is a bit newer. So what is your objective overall? Like, where do you want FTC Everybot to be in the next couple of years?
Yeah, so FTC Everybot, I mean, the ideal goal is to not have to do this, really. The ideal goal is to where either a kitbot is implemented or we spur on enough innovation in this kind of field to not really need to make an Everybot. But as far as we are now, our goal is to just provide a basic robot that teams can make and perform well with, and just have a good time, have an enjoyable experience with robotics. Which, I mean, if you have a broken mechanism or something that doesn't work, you might not have as good of an experience.
Jackie, let's start to break down what some of this robot looks like here. I mean, this clamshell design that you've came up with, I mean, talk about being very accessible for teams to create on there, very functional and durable as well too. So tell me a bit more about the inspiration behind it, and let's break down what it actually is.
Yeah, so I guess we wanted to create something that does not require accurate cuts on the aluminum. So all of this stuff is cut with a hand saw. So all the alignments don't need to be, the faces don't need to be perpendicular. And also all of the plastic 3D printed parts require no supports as well. So we've implemented a lot of tricks like teardrops for holes, and things like chamfers instead of fillets, and a ton of tricks to make the printing process as easy as possible. And we can also change this diameter here to adopt many different styles of tubing as well. And overall, it is modular as well, because teams can choose to expand, and if they decide not to build the rest of the robot, they can also use this modular setup to build any chassis. And it also adapts different motors from the market with zip ties, mounted with zip ties and bolts. And another cool feature is it's actually mirrored. So teams can download one file, mirror it in their slicer, and then they're just ready to go. And yeah, so the reason they're through holes as well, I've seen a lot of questions online asking us why we don't use heat set inserts or have hex built in, so you don't have to have a wrench on it. The idea is that you can use multiple types of bolts as well. So here we're using 632. It also works with M4 and M3, and 440 as well. So we're just trying to make sure everyone has access to some type of bolt that can work with this system.
The Everybots for everybody, right?
Yeah,
So
yeah, for everyone.
that's really cool. And just some of that thought process you've gone through with that, like not needing supports, like how crucial really that is, like to getting teams to create it, especially the first time. I love just all the thought process that's gone into that. Speaking of which, as well too, something we see in FRC a lot, but not FTC so much, are these herringbone gears as well too. So talk to me more about that implementation and maybe how it can be utilized for FTC teams.
Yeah, so a lot of people had a lot of concerns about the structural integrity of the herringbone and like the difficulty of printing them. So as you can see, we added these brims here so that the first layer is actually just perfect round. So that's going to be easier for some of the printers with little worse bed adhesion as well. And herringbone has an advantage of always centering itself, and it's really difficult to machine. So it's pretty much only achievable with 3D printing, and people had a lot of like concerns about like the durability of this, and we have not seen field failures yet. And we have like gone through a lot of like iterations of this gear to make it more durable as well. And so far we've had pretty good experience with it, and it is an easy part to replace as well.
Another thing that really stands out on this robot too, I think, is the tape measure on this, Elizabeth. So talk to me more about why even use a tape measure in the first place. Are there advantages to it? And then at some point, if we can see how that slide works, so let's bring in a sample and take a look at the intake.
So when we were thinking of how we wanted to be able to extend our arm, the first thing we decided on is that we wanted to use drawer slides for their accessibility, since you can get them at pretty much any hardware store. While we were looking at different ways to actually get the drawer slides themselves to extend, we started experimenting with some tape measurers, since again it's something you can get at pretty much any hardware store and something that we had a lot of. So the way it works is these compliant wheels push it out, and the reason we kind of went with these compliant wheels instead of like Coulson's or something like that is because the center, where it is not, there's no like plastic insert or anything like that, kind of acts as a built-in clutch. So an issue we ran into a lot was when it would overextend, the tape measure would keep going and you wouldn't be able to retract it. And so that built-in clutch kind of prevents it from ever kinking up like that and taking the arm out of commission for the rest of the match.
And Milo, I have to admit, like one of the more, I think, complex looking things on this is that intake that you have too. So can you break down how that is, and how does that intake still adhere to the Everybot philosophy as well?
Yeah, absolutely. So the intake might be one of the most dense or most iterated parts of this robot. It's a roller claw, kind of taken inspiration from either Change Up or the Robonauts 2015 robot Empire. So it's two free-floating pinchers, kind of, with a elastic between them and two compliant wheels to where a game object goes in and it just auto-corrects. A big part of this thought process during the prototyping phase was how can we make this intake as easy to use for new drivers as possible. So having that auto orientation in that intake design is crucial. Also kind of going off that with the early sketches and architecture work we did, it was just the optimal kind of positioning or intake design that we had prototyped for the kind of one-arm extension architecture.
And I think one of the most maybe Robonauts-esque features on this is your climber that you have on here. It really stands out on that. Can we demonstrate how the climber works and maybe talk me through it a bit more?
Yeah, absolutely. So we'll get down on the field and turn the robot on. But so the climber is kind of a very simplistic hook, but it's very easy to add. There are only 3 screws and a very simplistic, non-likely to fail 3D print. You just go back up and then you put the arm down and it'll climb by itself. So that will change slightly. We have adjustability assumed for the wheels, which will change height, and some other parts that will vary. But other than that, the climber hooks are easy to adjust, and they're very easy for new teams to just implement or even leave off of their robot if they needed to get ready for a comp.
Well, FTC Everybot, thank you so much for taking time to tell us more about this awesome design. The inspiration that you've been putting into the community for this is amazing. So we hope more teams take notice as well too. And thanks a lot. We hope you keep doing this throughout future years and keep up the great documentation. Appreciate it.